Dear viewers, today we are going to discuss about experimental designs. Today we only discuss about two designs, that one is completely randomized design and another one is randomized block design. So let's start. So we have first completely randomized design. So here we all know there are two principles of our design of experiment. Three principles actually. First one is principle of randomization, second one is principle of replication, and third one is local control. So in completely randomized design, we used only two principles of experimental designs. First one is principle of randomization and second one is principle of replication. So randomization, all we know the randomly assigning, and replication means repetition of treatments. So here the unknown term for us may be replication. So replication is repetition of treatments. So here replication, treatments, randomization, all are basic terms you all know about, but today we are just clearing the basic concepts about these completely randomized designs and randomized block design. So let's start about our topic. So see, look at this picture. So I have a experimental field. This is field 1, field 2, etc. I have 9 fields, and we have I have three types of fertilizers. Let T1, T2, T3 are fertilizers. So in our design of experiment, our main motto is to finding the treatment which is better, that is finding the fertilizer which is better for the farmers, we can say. So here in completely randomized design, our first principle is randomization. So we have three treatments and we have nine blocks, that is we can say 9 strata. So here we randomly assigning these three treatments to 9 blocks. Let randomly I choosing here treatment 1, here treatment 1. Let by tossing a coin or throwing a die, I can make decision about the assigning of treatments, that is fertilizers, to our experimental unit. So let here comes T2, that is completely in a random manner. So I just writing all those treatments in my experimental units. So here we can look, we have treatment 1 2 times here treatment 2, here treatment 1, etc. So we have second principle is denotes to replication of treatment. Replication of treatment means repetition of treatment. So here I replicate treatment 1 for 1 2 3 4 times, and treatment 5 times, treatment 2 for 2 times, and treatment 3 for 2 times. So that's all about the completely randomized design. In this design we just randomly allocate our treatments to the experimental units and repeat our treatments, so that we can get a great idea about all the treatments variations. So in completely randomized design we only use one-way ANOVA to calculate the variation of treatments. So why you use one-way ANOVA? So we all know for comparing the means of two factors, we use t-test. For let we have here 3 treatments. So here we cannot use t-test as equal to calculate purposes. So here using ANOVA by calculating sum of square due to treatments errors, total sum of square, we can easily calculate the variations of treatments. So that's all about completely randomized design. So here we have completely randomized design. So why we use randomized block design? So we have three principle about a design of experiment. So here we use the two treatments that are in the CRD, that is, here we use randomization to replication, and third is arises, that is local control. So for understanding local control, we take a small example about this, and theory thoroughly discuss about the concept of local control. So let's start. So here we have the same experimental unit as here in we take in completely randomized design. So we have here a kitchen sewage pipe that may contains water, that flows water outside the kitchen, and it must have some particles of vegetables or other organic materials. So we can say the plots corresponding to this sewage canal is more fertile, that is this area that I have scattered dotted. This may have more fertile, and this may quietly not as fertile as these three plots, but maybe quite mediumly fertile area, and this is infertile area. So by using our treatments that is we have used here, this plot gives us naturally gives more yield than these two plots. So here if we apply treatment one for 2 times here, so we cannot get the great idea about if our fertility is more due to the treatments, or these are due to the soil fertility is very high. So here we use local control concept. So in local control, what we do? So let's do the another design, same design. So we are just drawing the design. So here we have 9 plots, experimental units. So according to local control principle, here we dividing the experimental unit into 3 blocks. That is, let first this block is more fertile, since due to the kitchen sewage pipe flows through it. So this plot is high fertility area, high fertile. It is medium fertile, and this one is less or we can say infertile area, fertile plot. So according to local control principle, we divide our three that is, we can say, block into 3 parts. That is high fertile plot, that is these 3 are high fertile plot, and this has medium fertile, and this is infertile. So here we use one term that is called as fertility gradient. So fertility gradient refers to what? That is we listen a term many times, that the fertility gradients is in only in one direction. So here fertility gradient is like these plots are more fertile than those than comparing to these 2 blocks. So according to so how randomized block design is different from completely randomized design? So in completely randomized design, we are assigning the treatments randomly to all experimental units, but in randomized block design, we blocking the experimental plots into laid in 3 parts here, and inside the experimental inside the block we randomize our treatments. That is, inside this block I randomize my treatments. Let in here I give treatment 1, here I give treatment 2, and here I give treatment 3. So here then after this in this block I also assign randomize my 3 treatments. Let in here in treatment 2, here treatment 1, and here treatment 3, and here I randomize similarly treatment 1, here treatment 2, here treatment 3. So this gives us more information about our error term. Just error term means the chance variation or the natural variations about the treatments or fertilizers. So in randomized block design we get more idea about the treatments or fertilizers in comparison with completely randomized design. So in so here also we use two-way ANOVA since we have here block and treatments. So here we use two-way ANOVA to calculate the treatment variation between the blocks, within the blocks, etc. to and we compare our means. The basic idea is when the experimental area is homogeneous, we use completely randomized design. When not homogeneous, that is heterogeneous, that is we have a fertility gradient in one direction, here we use randomized block design. Not only in field experimentation, in any field we can use this concept to differentiate between completely randomized design and randomized block design. So in next video we are going to discuss about the efficiency of randomized block design in comparison with completely randomized design. Thank you.